Okay, so if I do this here, and we start by reviewing what we covered in last week's session. So what did we start talking about last week, guys? If you remember, we start covering about variables, names. We're going to talk today about binding time. So we're going a bit more level up, other than the grammar, the parsing, the compiling stuff. So we're going a bit of level up to also still talking about some of the main concepts when it comes to programming languages. So if everyone is in, so let's just remind ourselves, imperative programming languages. Do you remember we said these lectures, the next few lectures, are going to be covering imperative programming languages. So the variable that we talked about represent which part of the architecture of the von Neumann, the memory or the processor? It's okay, I know it's rusty. We're going to just review it by you answering the question. Memory, very good. Which one of these variables is considered to have a better name? Do you remember we said naming is very important? Why? It gives you a context of what's happening. So of course, it's going to be this one. Never mind the F by mistake. It's supposed to be A. I put F by mistake here. But of course, naming is very important for us because it gives you a context when you're reading to know what's happening. If you have X equal F, B equal A, you wouldn't even guess what are we talking about, right? Now in C language, if I have something like this, int score equal 80, int score equal 85, and then I want to print score and print score. So what would the output be? We're going to have 80 and 85. Why? Because we said the second thing about names is case sensitivity. Languages like C and the majority of the language that you're using usually are case sensitive. So the score with S capital is different than the score here. Correct? Okay. Now, what is the disadvantage of the case sensitivity? You said case sensitivity, it's used, but there is a disadvantage about it. What do you guys think? Very good. Why immutability? Is it because C is immutable? And we're talking about programming language C? Why do you think it's immutability, not immutability? Any reason? No? Okay, so the main issue in case sensitivity is readability, of course. I chose these randomly. It has nothing to do with the whole course. But readability, why? Because if you look at this, the first thing that you look at it, you're going to get confused. It's readability-wise, it's not good when it comes to case sensitivity. You may confuse things. But it's good that for the people, at least immutability is a bit related to C, but mutability, I have no clue why. The output of both is what? If I have this code, does it show? Let me check it here. This one. Last time we checked one of these, it worked, right? Not this one.
Do you have a disco ball?
This one, I think, right? Okay. So what's your answer? So I have void example. This is a function. Int x equal 10. I want to print the address of x, prints the memory address of x, and then I'm calling this function twice. Would I get the same address or a different address, guys? What do you think? Different address. Why? Because we said inside this function, I'm defining x, right? When this function is done, what's going to happen to this memory? It's going to be destroyed because this is a local variable. So when I'm outside this function, the memory associated with this x is destroyed. So of course, I'm going to call it again. I'm going to allocate a new memory to it. Okay, guys? So these are very important because these are very basic, as I said. Like in an interview, if you make a mistake with these, you don't even continue the interview, right? These are the basic stuff of programming languages. So if I ask you these kind of questions in the midterm, these are bonus questions, okay? Can I give a variable the same name? What do you think? We covered this. Can we give it the same name? Can I use x twice as a name? What do you think? So it's almost 50-50, let's say. Who says no is the majority? No, why? Logic behind no. If you give me a reason, then I'll be able to explain, yes.
It's ambiguous.
Okay. Any other reasons? Okay. You're right. So it's not recommended to use the same name, but I'm saying, can I use? Yes. When can I use? If I have int x inside the function, and I also have int x as a global variable. So it works, the program works, but as you said, actually, it's not very recommended. Why would you have the same name? It's going to be confusing, all of these things. Okay, guys? So technically, yes, I can. And a good example for it is local versus global variables. Now, what are the aliases occur when two or more variable names refer to the same memory location? Is this true or false? So aliases occur when two or more variable names, the same name, variable name, sorry, two different names, two different variable names refer to the same memory location. Is this correct? Yes. The value attribute of value, so it's one of them. So it's either the attribute of value or the value attribute, consists of two representations. Who can remind me first, what are the attributes of variable? It's a what? It's a 6 tuple, right? So some of them are what? Do you want to see the attributes of variable that we covered? Names, we already covered this. Address, we talked about that.
You just said what I was last saying, but there's also whether it's local or global.
So we can say scope, for example. Then time, lifetime, exactly. So that's 4. Then we have the value here, that's 5th. What is the 6th one? Samuel? The type. So these are the 6. Okay, so we're talking about one of the attributes called value, and we said it consists of 2 representations. Technically, we mentioned the L value and the R value. Which one refers to the variable address? It's hard for you to remember. It's going to be the L. The R value is the actual value, the element. So let's say I have x equal 5. So the R value is the 5, and the L value is the memory of 5. So the address of this memory that 5 is stored in. What is the variable's lifetime? One of the attributes is lifetime. Is the lifetime of a variable refers to the period during which the variable exists in the memory, or the lifetime of a defined global variable? Yes. What does scope of variable refers to? That's another attribute. The scope is what? The scope of a variable refers to the region of the program where the variable is accessible or visible, or the scope of a variable refers to the type of variables allowed to access it. So let's say I have inside a function int x equals something. If I have also another type int outside this function, can I still access this x? No, we can't. So the scope is what is actually referred to the region of the program where the variable is accessible or visible. Is Python language type considered implicit or explicit? Python. What do you think? The type. I choose Python because I'm assuming everyone have used Python and Java, of course, so far. Implicit or explicit? Who wants to help his friends here and maybe define or explain what implicit is or what explicit is?
It's implicit, you just have to like assign it to something and it will just automatically see what the variable is. But if it's explicit, you have to define all these.
Very good. So in the case of Python, it's implicit. Why? Because you can say x equal 5. This is implicit defining the type of x. That means x is going to be an integer. But in other language like Java, what do we have to say? Int x equal 5. You have to explicitly give the type to the x. Now, is the value in Java language considered static or dynamic? Before we move, who wants to remind us what is static, what is dynamic? Dynamic means can change, static means fixed. Now we're talking about the value. Before we talk about the value, before you answer this, if I want to apply the same question on type, we said if I want to have x equal 5, I have to say int x equal 5. Is the type static or dynamic? Static. Why it's static? You can change it, right? You said int x equal 5. You can just change your mind and say float x equals something. You have to create a different variable that is float, for example. So that's what means static. Now, if I want to apply the same on the value attribute, not the type, is it static or dynamic? Okay, so let's give an example. Again, int x equal 5. Can, on another lines, I say x equal 20? So what happened to the value? It changed. So the value is dynamic, not fixed. So the value attribute is dynamic, but the type attribute is fixed, is static. So that's the difference between static and dynamic, guys. Is it clear? Okay. Very good. So now let's start with the second part. So last time we covered, as we said, all the attributes, the names and everything. And today we're going to start talking about the concept of binding. Okay, so we covered names, variables. Now we're going to talk about binding, type checking, and then scope. So we can finish this chapter and move to the data type chapter. So the concept of binding is the same thing that we talked about, but we're going to just explain it in a different way now. When I say int x, what am I doing here? The variable is x and the type is int, correct? What did I do here? I'm doing a binding between the type and this variable. So it's as if you want to think about it, as if you're what? You're putting a label on something. Let's say you have a box. So instead of open it, you can just put a label on it that this, for example, is the kitchen utensils. Correct? So this X, I'm putting a label on it. This is int. That's the type of it. So I'm doing the binding. Now this binding will happen in different things. So what is binding? A binding is an association between an entity like the variable and an attribute. So that's the binding. So the association between the one of these 6 attributes and the variable. The key idea, as we said, when a program runs or compile, several decisions are made regarding variables operation. We're going to talk about it. Now, what is binding time? We said int x, we did a binding between the type and the variable. But we need to know that at what stage, at what time this binding happened. Why it's important? Because it's going to show us, was it done at the compiler design time, this binding, or was it done at the compile time, actually when you hit compile, that's where the binding is happening, or at the execution time, for example, the runtime. We're going to see some examples. Let's take this example, Java assignment statement. Let's do it together. We have count equal count plus 5. So there are several bindings here happening. We're going to talk maybe about the value, about the operator. We're going to talk about different things. So let's say I want to start with the type of count. Of course, the type of count is somewhere here, for example, int equal count something. So when is the type of count bound with the variable? At which stage usually when it comes to Java? I'll help you with this at the compile time. When you hit compile, that's when the binding is happening. In this case, for example, it's int or float. Now, what about the possible values of count? Not the value of count. The possible values of count. When would this association happens? Think about it. We're going to think together here. When you learn how to think, guys, during the class, in the midterm, or in the final, or in the interview, it's going to be easy for you. You don't have to memorize things. You don't have to go through these slides and try to memorize these because you understood how to think about it. So whatever I give you, whatever example I give you, you're going to be able to solve it. You don't have to study for 10 hours. So what is the possible values of count? Before the binding, what are the possible values of count? Who can give me an answer, random answer? Who can give me a wrong answer? Who can speak? Yes.
Our answer will be 3.5.
3.5. This is one possible value, for example. Exactly. What are the possible values?
Range.
Very good. Exactly. So it's in the range of something and something. Who decided this?
Design of the compiler.
Exactly. So when did we bind this? At the compiler design time. For example, with Java, it's known that it's -2 to the power of 31 to 2 to the power of 31 minus 1. We decide this is at the compiler design time. Now you're understanding more what do you mean by the binding time. Now, the meaning of the operator plus. When would this happen, the meaning of the operator? Now I'm going to help you a bit. Do you remember in the grammar, when we used to put the grammar, right, the BNF, we used to give more than one option. Why we're giving more than one option? Because we want to help the compiler decide what the semantic. So what are we technically doing? We're saying if you get an int, you're going to go this way. If you get a what? A string, you're going to go this way. Correct? In the grammar, we used to have, for example, whatever, 2 points, something, and then slash something. That means this plus, if I'm giving you an int, you're going to treat this as what? Maybe this option 1, you're going to choose it, which is an arithmetic operation. But if I give you a string, you're going to go to the second option, which is doing a concatenation. So when this is happening, when am I checking this grammar? Who's checking it? You remember the syntax analyzer and the semantic analyzer is part of what? Okay, so when I compile, so this is at the compile time it's happening. Because I wrote these before the compile time. Now I'm giving a plus, but because there's a count, for example, before it or after it or whatever, it's checking the grammar. This is happening at the compile time. Now, the value of the literal 5, it's at the compiler design time. Why? The value of the literal 5. This is because before we do this, we want to specify where are we going to store this 5, like the actual memory. So this we have to decide it on the design time. Am I going to store it as a binary number? Am I going to store it as a 32-bit, as a 64-bit? So I decided this, how it's going to be stored. Yes, Mike.
I'm a bit confused on the difference between compiler design time and compile time.
Compiler design time, so design. So before you press the compile on your machine. So the rules, you can think about it.
The previous example, when we're talking about the meaning of the operator, technically, wouldn't that be compile design time because we're defining it in the graph?
True. You defined it here and here at the design time. But who's going to take the decision if it's an arithmetic or a concatenation? When are this decision? Are you on the designer time taking this decision? You can't take it because you don't know the whole example. That's why at the compile time this decision will be taken. Very good. Yes.
So if we had a similar operator that only had one potential meaning, then that be.
Yes, maybe you can say at this time, for example, compiler design. Now we said the value of 5 at the compiler design time. What about the actual value of count? The actual value now, not the possible values. When would this? Yes? Exactly. Now it's obvious that this is going to be at the execution time, at the runtime. Why? Because at the runtime, when you run the program, this is going to be executed to say count equal count plus 5. So I think it's clear what we mean by binding times. Correct? Very good. Now, the next thing that we want to talk about is why binding is important. So with all these examples that I gave you, what did you deduce from it? Why it's important? What were we able to do? For example, when we talked about the plus, it helped us do what?
What you would call?
Yeah, which means what? What did we learn about this? Is this part of the syntax or the semantic? Syntax is already covered for us. Now we have to semantic, we have to understand the meaning, because the syntax, we know that if it's a plus, it's covered in the syntax, that's fine. But we need to understand more the meaning. So understanding semantics, the meaning, okay? Why it's important? Because depending on the meaning of the program, do I have, let's say, am I trying to concatenate strings or am I trying to add arithmetic operations? So this is more like understanding the meaning of this language. What am I trying to do at this point? Okay. So it's important. For example, if you take this example here, let's take this. I have void add numbers int a and int b, and then I'm calling this function here add numbers x and y. Having the binding time, understanding the binding time and everything is going to allow me to understand that this x and y has to be what? Has to be ints to be able to function. So that's why when I pass, I need to pass ints. So this is usually part of the importance of binding time. Now, possible binding times, the same exact thing that we covered, but there is also more times. So we have the language design time. So this is even before the compiler design time. So bind operator symbols to operations. In this case, the plus operator was bound to addition during the design of the Java language, this binding part specification, and then the compiler design time, bind floating point. So this is what you asked, Michael. So for example, here, we have this at the language design time. And then here, we have that this float is defined, for example, from this range to this range. And then here we have the compile time, bind a variable to type in C. So these are the same example. I don't want to go through them again. So now let's start talking about static and dynamic binding. We covered this last time, right? And in the WOOC lab, we answered what is static and dynamic. So very quickly, static is something that's fixed, doesn't change. So for example, int count equal 10, we cannot change the type anymore here. This is static binding. What is the dynamic binding? We gave an example of the value, correct? So we already covered this in the WOOC lab and last time. Now we want to move to type binding. We want to talk a bit more specifically, not just about the general binding, just about the type binding. We already covered, this is just a reminder that we have explicitly declared type that's explicitly declared. We said implicitly declared is like this. So when I say x equal 10, I'm implicitly declaring that x is an int and y is a float. And then we said static and dynamic, but when it comes to type, in this case, Python, is it considered dynamic typing or static? We said dynamic. Correct? We're just repeating ourselves at this point. Now, dynamic type binding, you can find it in JavaScript, Python, Ruby, PHP, some limited things for the C#. And this is an example in the JavaScript. That's what I want you to focus on. Advantage is, of course, flexibility. It's more flexible, it's more maybe easy to use, but the disadvantage, other than the high cost of this, correct? There's a high cost dynamic type checking and interpretation. We're going to talk about it a bit later, but this type error detection is going to be hard. Why? It's easier, guys, to make mistakes. For example, if I give you x, sorry, for example, I have x equal 5, and then I have also y equal a array of something. Then I said I equal x. Okay, so what is I now? I is an integer. If I say I equal y, would this work? Yes, I can just, it's dynamic typing. I can just change the type of I to an array. What if I did this by mistake? I didn't mean to say I equal y. By mistake, I did it. When would this be figured out? Not at the compile time. So it would be like you're searching, why is the output is doing this? What's happening? You're going to go and check the error. And then at the end, it's just a small mistake that you called y instead of x. But let's say in other languages, this will not even run. At the compile time, it's going to stop you. There is a type error, so you'll fix it and then continue. So that's one of the main problem when it comes, main disadvantage when it comes to dynamic typing. Now, other than the type binding, we have the storage bindings. What do you mean by storage binding? The same way this variable. Yes, Benjamin.
For type binding, we can have a function that takes in type as a variable. So let's say it's just creating a list of a type that you specify. We can say new list and then put type as its own variable. So we take on int or float or whatever at compile time. How does that affect the binding? Like when would it be assigned type as its type?
Type is always happening at the compile time. If it's a static type, like if it's something that you're implicitly or explicitly, type is always at the compile time usually. Because when you compile it, it's going to check that type. Okay. Storage binding is what? The same way we're binding a variable and type, what are we also doing? Let's say I have x equal 5. We said x equal 5, the value has 5, and what does it have also? Address. Very good. This address is pointing you where? To a memory cell. That means, is there a binding? Is there a bind thing between this variable and a memory? Okay, so that's storage binding. What do we usually call them? Allocation and what? The allocation. So now when you hear this word allocation, we're talking about storage binding. So you know what we're talking about. So technically, you're allocating a space in the memory for this variable. That's called storage binding. Or you're getting rid of it. Let's say you finished your function. You want to destroy this cell. You do what? Deallocation. So these allocation, deallocation are storage binding. And then we said the lifetime of a variable is the time during which it is bound to a particular memory cell. Okay, so the lifetime of this is this. Now, this is the same thing, but from the slides of the book. So before we move to type checking, let's talk a bit about the types of operations. What do we have as type of operations usually? What are the types? It can be what? Boolean, arithmetic, string, assignment. We can have multiple type of operations. Okay, guys? So if I want to do type checking, why did I mention these types? Usually, if you assign a Boolean to a whatever string or something, you have a type mismatch, correct? So we're going to talk a bit about it. How are different languages handling this type checking? So what is type checking? Type checking ensures that an operator, when it is applied, gets argument that it can handle. So type checking is done at compile time or at runtime, depends on the language. Now we said the type error occurs when an argument of an unexpected type is given. Now let's see how different languages will handle this. All the languages will have something called type error or type checking, but some languages are more strict than others. For example, Java is known to have something called strong typing. So it's very strict on it can catch so many different things on the compile time. That's why when you're doing Java, sometimes from the first 7 or 8 tries, you're going to always find lots of errors. But the good thing is that you're going to fix them and move on. Other languages are not very strict. That's why it takes you a bit of more time to find the errors. So let's take an example. I have an enum day. I have these stored in it. So let's say these are strings or whatever, or like values or whatever. We have workday, also have this. Now inside the main function, I'm defining X, but with type day. I'm saying day.mon. And then I'm defining Y with a different type called workday. Workday.mon. If you look here, they are the same thing. But when it comes to Java, it's going to give you an error. That's actually called strong typing. That's very strict thing that Java does. It tells you, okay, I understand, okay, this is maybe the same thing, but for me, no, I need things to be very clear. I need things to be very organized. So because I want to be able to handle the error better. In other languages, it may not be like this. Yes?
Fix this though by subsetting.
But we're not talking about fixing. We're talking about explaining the concepts. Of course, you can fix it, but we're explaining the concepts, but very good. Programming language has strong typing, as we said. What do we mean by strong typing? When all type errors can be discovered at compile time. So that is the goal of strong typing. Okay, so in this case, as we said, Java is an example of strong typing. Now, as usual, life is not perfect. So technically, it's going to be super, super hard to actually figure out all the errors at the compile time. So there is a more relaxed definition of strong typing. It's called preferably at compile time. So we're going to say all errors can be discovered preferably at compile time. Because even Java has some exceptions for this. Okay, so it's very hard to actually have this perfect strong typing. As we said, it's interesting that no popular programming language features perfect strong typing, but one of the best languages that have good strong typing is Java. Let's take another example about strong typing. So Java performs strict typing, checking at compile time for almost all cases. It has the type mismatches. This is part of the strict typing. So like trying to assign an int to a string, this is of course not going to work. But and then also it has these generics in Java help to maintain strong typing. By what? If you remember, if we say usually in Java list integer, you're actually saying I can only have integer inside this list. Okay, so this is just to protect the type. So let's take an example. So as we said, however, even Java is sometimes have relaxed thing. For example, typecasting, generic type eraser, and other things. So we talked all the good things about strong typing. What is something not so good about this? Yes.
Can't have a list with multiple different types.
Yeah, so in general, as a general answer, it constrains you. So technically, sometimes it's impractical, correct? Like too many rules. Okay, give me an example. Let's say you want to multiply an int with what? With a float. Theoretically, in real life, that's fine. Why would it be something that's not good? But in Java, it doesn't allow you to do this. What do we usually do in Java to be able to do this? We have something like this. How can we solve this issue in Java? So we have float x, and then we have int n.
It uses implicit casting to cast n into a float.
Exactly. Usually we have to actually do this. You have to cast it like that. So this is impractical sometimes, right? So this is one of the main disadvantages of this very strong typing. It is good many times and many occasions, but sometimes it's a bit annoying. Okay. What else? Okay. Now there's another way that's not used by Java. It's used in C, for example, called correction. So we're not going to go deep in it, but it's another way to actually solve these kind of problems. So in the case that we talked about, it's going to represent the value of n as a float and use this new but equal value in the multiplication. So there is like another way to solve this problem. Usually C and Perl are examples of languages with exaggerated use of correction. So there is more than one way to actually solve this problem. Now, the most important thing, we want to move to it, which is scope. Why scope is one of the most important attributes. What we were talking about in a bit, the meaning of a language, right? So let's say you have a perfect syntax, and also you have a very good understanding of the semantics, of the addresses, whatever, everything. But what's happening? You don't understand, or you're not following the right scope. So you're following the idea of X has the same type of Y, so that's why I can communicate between them and everything. But let's say that your program doesn't know the scopes. So, and you're going everywhere between global variable and local variable. So you're going to end up with the wrong answers. That means you didn't actually fulfill the meaning of this program. If you wrote a program for a specific calculator thing, that's all the calculations is happening inside a function, but you're not following the right scope and you're calling a global variable, the whole meaning of this program is wrong. So let's take a look at it. As I said, this is the most important factors in gaining an understanding of variable, which is the scope. The scope of a variable is the range of statements in which the variable is visible. Okay, so where is this variable visible? Inside the local function, outside, all of these things. A variable is visible in a statement if it can be referenced in that statement. And let's start taking an example. Before we go in detail, what is a block of code? Of course, this is a block, right? Java, C++, and other languages, we have different way to have a block of code. For example, other languages will have a begin, end. Some other languages have brackets, parentheses, for example. But this is the most common one that you usually use. So this is a block of code. The simplest way to understand scope, we said that you cannot use X outside of this block of code. So that means the scope of X is just inside this block. Do we all agree on this so far? Okay. What is one of the advantage or one of the main goal of blocks? Of course, to organize the code. So imagine you write a full code without functions, without any blocks, it's going to be messy. That's why we always recommend to have blocks. And then we said the block defines a section of a code, and the scope is what we mentioned, which is very important for us. Now, this is what a nested block. We usually see it a lot in the nested loops, for example, but nested block, when you have a function inside another function, all of these called nested. Now, what is the main thing that you're noticing here? When I'm accessing X, I'm able to access it. Why? This block is inside the outer block. So I'm able to access anything defined in this outer block, correct? But does this outer block able to access Y? No. Okay, so that's the main idea here of scope. And we're going to see how is the program understanding the scope, because now we're looking at it, we're understanding it. But how is the machine following this? Okay. So blocks can be nested. This means you can have a block inside another block. Local binding, names declared inside a block are called local variables. So we covered all of this. Now we're just putting them together. And if a name is used in a block but not declared, it must be declared in an outer block. Now, if I didn't have this, would this work? No. So at least I need to have like X here, then it will work. If I don't have X here, it has to be defined in an outer block or as a global variable, okay? Now let's solve this together. We use the white now, white color, so it's be clear for everyone. Who wants to help me figure out what is the right A output? Try to solve it first, and then we'll do it together. You have an answer? Okay, we'll wait for everyone then. So who wants who got the idea of right A? Who have an answer, even if you don't want to participate, just if I want to see if anyone got an answer. So 1, 2, 3. Okay, very good. More than half of the class. Okay, who doesn't have an answer and wants to solve it with me? What do you guys think? The sooner someone sacrifices himself or herself, the sooner we're going to be able to continue, yes. So yeah, so walk me through it. What's happening? I'm here, I want to do the right A. A is what?
X plus Y.
X plus Y plus Z. From where did you get the value of X?
From like the most outer block, so.
This one. Okay, so I have here A equal 1 plus Y. From where did you get the Y value?
The B block.
From the B block. Why you're able to do that? Because C is inside B and inside A. So I have here plus what? 2. Now Z, you have two options. You have this Z and you have this Z. Which one are you going to choose?
The Z equals 3.
The Z equals 3, this one. Okay, so this is giving you 6. But there is another alternative here, guys, that it may be what? 1 plus 2 plus this Z, which is equal 5. Why didn't we choose this? Yes.
Because it's from an outer scope, and the inner scope takes priority.
Very good. Do you remember, guys, when we said a variable can have the same name? That's actually one of the examples. It's not just global variables. Even here, we can have the same name. But whenever inside a block of code, whenever I see an assignment, a definition of something, then I don't look outside the block anymore. I have to use this one. So I have to use the 3. So it's going to end up with 6. Now, in this case here, write B. Margaret. Catherine.
Yes.
Because you wanted to solve the first one. You want to solve the B?
B equals X plus Y plus Z. And we got the X from block A.
Okay.
Y from B.
Okay.
Use the Z inside of the C block because we're outside of it. So we have to use everyone else in B.
Very good. In this case here, I don't have a local Z and I can't access the C block. Okay, it may seem super basic for many of you that we are very comfortable with programming, but others who are not very comfortable, you need to understand these things. Okay, guys? So now 6 and 5 here. So how is this? Because this one should, as I said, if you know how to program, it should be maybe makes sense for you. But how are this translating to the machine, to how is the program understanding all of this? It's understanding all of this based on the visibility. Yes.
I had a question from the last slide.
Yes.
If we're in the C block, A equals X plus Y plus Z, are we able to do like B dot Z and C dot Z and refer to them separately? We can take both with it. Or would it only just one as the other?
I think you can. I think you can. It depends on the language and things, but you should be able to. Yes, because here inside the C, you're able to access what's here, and what's here. So you're able to access all of them. So you're able maybe to do these things, but I think it depends on this exact language, how you're able to call them. But good question. Now, how are we doing this? How is your machine, how is the program actually analyzing this, what we said? If we take a look here, we can say, we can represent this by nesting diagrams. So let's look at this nesting diagrams. This diagram here represents the P. And why do you want to represent it like this? Because it represents the visibility. And based on the visibility of these variables, your language or your program is going to be able to understand what is exactly the meaning of this program that you wrote or this code. So P includes what? X, this one, also includes a function A, includes a function C, and then a statement P, okay? Now, inside A, we have the Y, we have another function B, and then a statement A, SA. Inside B, we have a float Z, and then a statement, and then here, C, we have Z and C. Good so far? This is called a nesting diagram. This is one way to represent this on paper. Another way, we're not going to go through it a lot. You can find it in the book with more descriptions called graphs. This is just a way, like a graph theory that we learned in data structure on the way how you're calling these functions together. We're not going to go too much into this. I want to be back to this diagram. So let's understand the visibility. If I'm here, guys, at B, what is visible for me? So this is going to answer your question. What is visible to B? Which arguments, which floats, which integers are visible to B? How many variables do we have? We have X, we have Y, we have Z, and we have another Z here. Correct? So what is visible at this P? So if my program, if I'm here, what is visible to me? If I know what's visible to me, that means I know my scope. That's what I can use. I cannot use anything outside of my visibility. You want to help me? Ibrahim, right?
B.
Yeah. So what is visible to me? So you're here, start from here. So you're here, so that means Z is visible. What else? Y is also visible. What else? And then X is visible. So technically, it's like this. P dot X, P dot A dot Y. So that's the thing how you go. And then P dot A dot B dot Z. So that's what's visible to me. I cannot use anything outside here. That's why my code now is able to not give me any hallucinations. He knows what his scope, he knows his limitation, he knows, and then he's able to do everything properly. Now, what is visible at this stage S, A? So if I'm here at A, what is visible to me? Yes?
Y, B, and then values of P, so X, A, and C.
So X, forget about just the value. So X and?
Oh, where are we starting from, sorry?
So here, I'm at A. So Y.
Oh, okay. Yeah, so you have Y and B, and you have your statement A, SA.
Mm-hmm.
And then the statements of, or not, the statement of P and X, A, and C.
Exactly. Can I have access to Z? Can I have access to C? No. So it's going to look like this, P dot X and P dot A dot Y. So we're only mentioning not the functions, we're only mentioning like the variables. Okay. Now at C, what do I have access to? Very quickly at C here. X, of course, and then only C. This P dot C dot Z is different than what P dot A dot B dot Z. You see, they are different. Same name, but different. So there will be no confusion now when I'm giving this. If my program is able to understand the scoping, there's no confusion. What is this called, guys? That's called the static scoping. So there's two types of scoping, static scoping and dynamic scoping. So this is static scoping. All the popular languages use static scoping. They use the same idea that we did. The other type of scoping is called dynamic scoping, and it's not used anymore, very limited in a very specific case. We're going to see it. If I take this example, so we're going to take this and after that, if I'm taking this example, guys, I'm using the static scoping, the same thing that we saw in the nested diagram. I want to print X. What's going to be X? So this start main, and then it calls, for example, B. So who wants to do it? If someone is still confused a bit about the scoping, we want to take this. So my program main function, and then it calls B function, and I have B function, I have A function. So what would be print X? Let me see more people. That's our last slide, guys. Even if you don't know the answer, but you're confused, tell me so I can go step by step with you about this.
I think it's 24.
Okay, take me step by step. So what happened? So you're at main, you're here. Okay.
So start with B, and B declare the new variable X, and X is
So no, before you declared X equal 23. Okay, so that's your first step. I have X equal 23 now. Now I went to B. Okay, so I'm here.
You declare a new variable X, X equals 17.
17.
That's specifically for B, so that doesn't affect the global X. And then you go to A. A is not in the scope of B, so you go back to the first X, which is still 23. You add 1 to it, it becomes 24. You print 24.
Very good, guys. Very good. Who is still confused about this? You want to say what?
Say 18.
Yeah, so tell me what. So exactly, I need to hear your logic so we can explain and answer. So what's the logic of 18? So we have the first logic that we have 24. The second logic is going to be 18. Why 18?
So we declare X at the start of the main, and then we set it to 23 before calling B.
So okay, so we have 23. I called B, I'm here.
So then we declare, I guess it's a new X.
New X, which is 17.
17.
Okay.
The function just edits the global X.
Okay, so here I'm inside A. You're saying because I defined X or declared X again, it should follow this X because this is the X was declared after this X.
That's what I was thinking, but I don't think that's right because in B, we're making a new X, whereas in void A, we're using the global X.
Very good. Any other answers? No. Okay, so looks what will happen. Guys, am I passing X here? I'm not passing X. If I'm passing X, now when I go here and I have X here, where is this X coming from? This B. So it's going to be 17 plus 1. But I'm not passing X. I'm just calling A. So if I'm not passing X, and this is local to only B, so when I'm done from this, I'm going to go here. This is going to be the X here. Okay? So this is called static scoping. The same idea that we did. Now the dynamic scoping is going to think like I'm not going to go step by step here because static scoping also means lexical scoping. So I'm going to go step by step. Now the dynamic is going to say, okay, I'm calling B. When I call B, that's it. I defined a new X. I'm going to use this as my global variable. So if I'm going to A, even if I'm not passing X, because I'm following the steps of a functions. That's it. So I'm going here. I'm going to treat now this as 17. So for the dynamic is going to be 18, for the static 24. Of course, as we said, most of the popular languages, they follow static. We don't follow dynamic. It's not it's not very clear the advantage of it, but in the past they used to use it. Yes, Mike.
So for example, inline functions, it takes the function and it puts it into, so for example, in this case, if we define A as an inline function, it takes the code of A, puts it in B.
Yeah.
In that case, would A be able to access the X from B?
No, that's how the dynamic is thinking, because this one here, you're calling the function. So you're treating as you're thinking. So you're as if you copied this code here. So that's the dynamic. That means, okay, I'm calling this function, that I'm treating this as part of the other one. But static, no, say, okay, this function is treating separately. So this is the static. So this what is the global for this is this one. Do you see that's the difference? So actually the other one, what you're saying is the more like the dynamic way. So dynamic, as we said, it's not used much today. Even the common Lisp that used to use this dynamic is switching to static scoping. Now, dynamic scoping is easier to implement, as we said, because you're just following the function thing, but it's not possible to understand at compile time. So that's the problem. And also internal variables are not protected. So there will be more issues when you're doing the dynamic. That's why everyone is just switching back to static. It takes a bit more time to implement the idea of static scoping, but it saves you lots of errors and other things. And that's it. Good. If you have any questions, let me know. Let me just